Welcome. As mentioned in the previous video, even in this video, we are going to continue our discussion on normal distribution. Okay, basically, whenever we have some density function, if we integrate it in the prescribed limit, we will get it as 1. Okay, here we have exponential, and in the exponential, we have some square term, so it is not that easy to integrate. Only when we have the idea about gamma functions, gamma integrals, we can integrate functions of this form. Okay, so just like in the previous distribution, that is the uniform distribution, we have a density function. Whenever we are in a need to find the probability, we just integrated it and found out. Okay, not only in the uniform distribution, be it any continuous random variable, we can do the same. Whereas in normal distributions, it may not be possible because this finding the integral, this integral is quite tedious process. Okay, if the limit is involving infinity, we are somehow able to manage it, whereas in other cases it is not that easy. So through computer programming and all, people have derived and found some table of this form, whereas this table value is not applicable for all the random variables involving some random mean and variance. Okay, that is why we have something called standard normal variate. That is the normal distribution with mean 0 and variance 1 is called as standard normal variate. Okay, suppose we have something like suppose we have x which is following normal distribution with mean mu and variance sigma square. In that case, what can we do to obtain all these things? We know expectation of ax plus b is nothing but a times of expectation of x plus b. Okay, similarly, variance of ax plus b is nothing but a square variance of x, and variance of a constant value is 0. Okay, having these two things in mind, you can find a standard normal variate just by substituting x minus mu upon sigma. Okay, now you try to find out the mean of it. It is expectation of x minus mu upon sigma. Okay, so expectation of x minus expectation of mu, and this is sigma, which is a constant quantity, so it remains the same. So expectation of x is what? It is simply mu. It is a constant mu, so mu minus mu upon sigma, which is 0. Okay, now let us try to find out the variance of z. Since this is a constant quantity, okay, it is 1 upon sigma square of variance of x minus mu. For constant, it doesn't matter. So it is 1 upon sigma square of variance of x itself, which is nothing but sigma square. So this is the proof that this substitution, that is z equals x minus mu upon sigma, is actually converting your normal variate into a standard normal variate. Okay, when you give this substitution, you are very well able to see that your density function becomes something of this form. Sigma is 1 and mu is 0, right? Okay, here also you can very well try to see the graph of the normal density. Here we have shown some graph, right? So this red one, this red one is the graph for standard normal variate. Okay, and moving further, this distribution function, it is generally probability of z smaller than or equal z, that is from minus infinity to z, and this is given in the table, statistical table. Okay, suppose here, so the graph would be somewhat like this, and it has the mean 0, so it is symmetric about 0. Okay, as it goes, so it will get closer to 0 but it never touches it. Okay, so here if you see this table, it is a one-sided table. From here only they are starting. They are not considering from minus infinity to this point. From 0 only they are starting. So from 0 till some point. Suppose if you are trying to locate, okay, let me go back and come here again. So through this table we will calculate it. Okay, and here we are given with some results. F of minus z. Okay, what is capital F? It is the distribution. Okay, f of minus z is same as that of 1 minus f of z because of the symmetry. Okay, this substitution, suppose you have to calculate the probability that x is taking values between a and b, you can just do the substitution and find it. Okay, now in this problem we are asked to find out probability of z smaller than 1.5. Okay, let us come here. 1.5 means you will have to look for the most. Okay, so 1.5, so this one you can treat it as 1.50. Okay, we are trying to find out probability of z less than 1.5. So this 1.5, whatever may be the given number, you just round it off to two digits after decimal point and try to look in the inside the table. So this first two digits you will have to see in the left side. Here is where your 1.5 is. The next is 0, which means this 1.50 you are writing it as 1.5 plus 0.00. So your 00 is here, right? So the intersection point is this. So this is your probability. That is, you are looking for this 1.5 here. So this is the probability that you have considered. But whenever they say probability of z smaller than 1.5, your table is giving only from 0. Because here the total area is 0.5 from minus infinity to 0, because it is symmetric. Symmetric means what? Whatever is available at the point of symmetry from minus infinity to 0 is same as that of 0 to infinity. So this is 0.5 plus the value that we have found from the table. Okay, this is a one-sided table. There are two-sided table also available. If you are using two-sided table, you can very well identify that you are using two-sided table from this value. At 0.00, if it is starting from 0, it is one-sided. Okay, if it is starting from 0.500, it is two-sided. Like from minus infinity, they are calculating it. Okay, moving further, next we are asked to calculate from probability of 1 to 2.2. Here what we can do is that first let us try to find out probability of this one minus probability of, because when we calculate till 2.2, okay, suppose we are using only one-sided table. Okay, let this be 2.2 and let this be somewhere 1. Okay, we need only this area. But what we are doing is that first we will calculate this entire area. Okay, and let us calculate this area. Okay, from the green, if we subtract blue, we will get red. This is what we are going to do. Okay, so the question here is, just a minute, let me erase these things off. Okay, the question here is find the probability lying between this two. So probability of z less than 2.2 minus probability of z less than 1.0. Okay, since all these are continuous distribution, whether you are including this or excluding this, that doesn't matter. Okay, 2.2, which means 2.20. 2.2 is where here, 0 is here. So this is the value that we are looking for, that is 0.4861 minus 1.0. So it is here, that is 0.3413. You may ask me now that previously when we have z less than 0.2, I asked you to add that zero point 0.5. Okay, no issues. Add zero point 0.5 here as well. 0.5 plus 0.4861. This is the actual value. Okay, because here if you just consider only this 0.4861, it means you have calculated from 0 only. If you are calculating from infinite minus infinity, you will have to add this. Here also the same, zero point 0.5 plus 0.3413. Anyway, this 0.5 and 0.5 cancels and you are left with this 0.4861 minus 0.3413. You just do the calculation and this is the required probability. Moving further, here you are asked to calculate probability of what? Z greater than 0.5. So probability of Z greater than 0.5. Now that we know probability of 0 to infinity, we know, minus probability of 0 to zero point 0.5. If we have these things, this is the remaining. Okay. Now let me explain why is it so from the bell shaped curve. Let this be the mean point. Okay, that is 0. Okay, somewhere we will say it is 0.5. We need this area. This is what we need to calculate. But what I am saying is that the table is available from this point, this 0 to something. So this we know. This we can find. This green color thing we can find it from the table. So what I am doing is that from this to this. Okay, that let me use another color. So this whole stuff, this entire blue stuff is zero point 0.5, that I know. So I am going to find the green part and subtract it from the blue to get red. So what will I have? It is 0.5 minus, where is 0.50? It is here, here. So this is the required value. That is 0.1915. I just have to subtract it to get the probability that z is greater than 0.5. Okay. Now that I hope you guys have understood how to use this table. So here probability of z less than minus 1.5. This is what we need to calculate. How are we going to achieve it? Now consider this curve. So your minus 1.5 is somewhere here. Okay, so this is the area that you are trying to look, and here you will have this 1.5 as well. That one so this green area and this red area are the same. Okay, if you are using a two-sided table, that is, some tables will give you, okay, just a minute, let me see if I can get those table as well. Yeah, I hope you can see the things that is going on in my screen. So if you see here, it is a two-sided table, where because at 0.00 it is having 0.5, so it is a as the curve says, from minus infinity you are evaluating. So if you have this table, now we need to find out z less than 0.15, isn't it? So we can directly read it from the table if we have two-sided. Okay, that is from minus infinity to some point. If we have this table, we can easily read this value. Suppose we don't have it, we have only this table. How to read this value? How to read this required probability from this? Okay, we know that it is same as that of probability of z greater than 1.5. Okay, how did we achieve it? It is probability that z lying between this quantity, this is same as that of this, isn't it? Now that this 1.5 is available, this 1.5 is available in the table, that is 0.4332. Okay, and we know that this is 0.5, so 0.5 minus 0.4332. So this way also we can find it, provided when we have only one sided table. Okay, when we have table of this form for this kind of graph, we can perform like this. If we have a two-sided table, it is well and good. Okay, and for this last case, that is probability that is lying between this and this. Supposing, so we will have something of this form. Okay, so minus 2.9 would be here and 2.9 would be here. So this is the area that we are looking for, isn't it? So in this case, what you can do is that from 0 to 2.9. Okay, let me differentiate that in different color. This blue one and this green one. They both are same. What I mean to say is that their area, their probability is the same. So this one you can write it as simply, that is probability of minus 2.9 less than z less than 2.9 is twice the probability of z lying between 0 and 2.9. This 2.9 is available in our table. You just find it and multiply it with 2. Okay, supposing you don't have that in your you have only two-sided table like this one. So in this case, what you should do is that you will have to find out the probability for 2.9, okay, and subtract it for minus 2.9. Okay, that is how you will end up with the actual probability. Okay, hope you have got the idea of how to use the standard normal table, and we have a few problems which deals with this normal distribution that we will continue it in the next video. Thank you.